Hi everyone, I am Amulya and I'm here to present Arrayán, a blockchain-based resilient food supply chain application built on the top of ResilientDB. The project is initiated by Mariana and it is developed under the supervision of Professor Mohammad Sadoki. This is the agenda for the day. Talking about the problem statement, the problem directly relates to the food supply chain. In the food supply chain, we have the farms. The products out of farm reaches the industry, then the processing facilities, then to the stores, and then directly to the hands of the customers. However, there are many food byproducts which are involved in the first two stages of the food supply chain. These food byproducts are rich in valuable molecules which are used in the cosmetic industry, and then they are being used by the hydrogen producers, animal farmers, and there are many upcycling companies who wants to track these byproducts. These depends on the chemical composition, yield of the products, and it again depends on various environmental factors and the growing processing conditions of the food supply chain. However, there is a lack of information and the tracking of these food byproducts. And these food byproducts go unclaimed forever. As of a report in 2022, we have 11.79 million tons of unvalorized food byproducts across the globe, and it is a high time to protect these food byproducts. Presenting our solution, we have the upstream food supply chain and the stakeholders that valorize the byproducts. And we are Arrayán, who acts as a bridge between the most important parts of the food supply chain, acting as an online market for secure, transparent, and safe food supply chain operations. Arrayán is built on the top of ResilientDB and it helps to track food byproducts, products, process history, and it serves as an online market throughout the food supply chain. The main goal of Arrayán is traceability for sustainability. We are here to make the better planet and save these food byproducts go unclaimed. This is the tech stack used. We have React in the front end, authentication by the Google Firebase, and the middleware of Python and the GraphQL servers. And the infra of the product is the ResilientDB. We have also used Google Firestore for better indexing and caching. These are the features of the product. We have inventory management, which supports the upload of Excel files by the user. It also provisions the user to manually input the products developed in their form. It also integrates with Innovent, which is a software being used by the user Davis binary, and it provides real-time visualization of the current inventory status. We have simple and intuitive food supply chain tracking. We can just search for a product and it gives you the entire food supply chain. We can also claim the food byproducts along with a few notification and alerts given on the screen. This is the architecture of Arrayán. Talking about the initial inventory manager, we have the inventory manager here, which takes in the user input of an Excel file or the manual input, and then we'll parse it. The parsed data is being sent to the ResilientDB by the post transaction mutation, which returns back the transaction ID. The transaction ID and the signer public key, everything gets stored on the Firestore. These transaction IDs are stored to make point queries at the later point of time whenever we are tracking the food byproducts. The transaction IDs are being saved to various documents we have on the Firestore, which accounts for the metadata which is used to display the dashboards and user transactions and the products. Finally, we'll have the success or the error of uploading the inventory to Arrayán. Next building block is the product tracker and the claim workflow. Upon triggering a search of the product, we'll fetch the transaction IDs from the Firestore. Since we have the correct transaction IDs, we'll be able to make the exact point queries on the ResilientDB, and we have the response back to the user. We will be showing an entire food supply chain, and if the users wants to trigger any claim of the byproducts, We'll be handling the claim by first constructing the transaction and then sending the updated transaction by the post-transaction mutation of ResilientDB GraphQL server. After that, we'll do the same thing of updating the transaction IDs on the Firestore. And finally, the claim will be successful or fail based on the login status and the network. So we have used Firestore, which will help us to make the point queries, and we are ensuring that we are keeping less load on the ResilientDB. This is the overall architecture of Arrayán. We have authentication, and after getting authenticated, there is a dashboard displayed. The dashboard fetches data from the Google Firestore. And during the entire process, we are making sure that we are we are utilizing less bandwidth of ResilientDB, and we are making the queries which are only required to complete the transaction. Next, we have the inventory manager, which uploads the data to ResilientDB via the GraphQL server. After receiving the positive response from the server, we upload the transaction IDs to the Firestore. These transaction IDs are used in the product tracker. So whenever user searches for any product, it fetches the transaction IDs from the Firestore and then asks the GraphQL server about the data of those transaction IDs and displays. And after fetching the information from the GraphQL server, it displays the information to the users. In this way, a secure food supply chain is built where we are displaying the every stage of the supply chain along with the product details at every stage in the supply chain. These food byproducts, we are also showing a list of byproducts, and the user can claim the byproducts. So after clicking on the claim button, we are updating the transactions on the Google Firestore and also updating the transactions on the GraphQL server, which again updates the ResilientDB. So in this way, we are building the entire food supply chain application with the core of ResilientDB. Here are the few projects and the recognitions which had occurred across the process of developing Arrayán. So Arrayán stood as a semi-finalist at Lineage Food Chain Innovation Challenge 2024, and we were invited to participate in the challenge on the November of 2024. On the similar grounds, we have also developed Respirate, which is a blockchain-based carbon emission tracker built on the same tech stack and the ResilientDB. We stood as a runner-up in the hackathon, which is hosted by AI Institute for Food Systems in 2024. Along with this, I have also developed an ag GraphQL wrapper, which serves as a common platform for all the ag apps which are built on ResilientDB. We can go to the demo of the application. Before going to the demo, thank you, and you can scan the QR code to help us build a sustainable food supply chain application. Coming to the demo, this is the website of Arrayán. Arrayán is hosted at arrayán.resilientdb.com. We have some information here, then some intuitive graphics, then what is Arrayán, why you have to choose Arrayán, and some statistics and dashboard of the number of transactions and the products which are currently being entered into the system. So you can see the number of transactions occurred at every month. Then talking about the inventory manager, you have a menu called My Inventory, which helps to track the inventory which is uploaded. So I'll just upload any Excel sheet. We got this data from UCDB binary, and utilizing the same data here at Arrayán, I'll display the inventory. So basically, whenever you upload any Excel file, we are parsing the Excel sheet, then saving the transactions to the ResilientDB, fetching the transaction IDs from the ResilientDB, and posting them to Google Firestore. The Posting the transaction IDs to Google Firestore help us to make point queries at the later tracking. I think it is taking some time. I will show you. Yeah, this is how the table looks like. We have all the products which had occurred across the food supply chain. Okay, yeah, here you can see the same thing. We have all the products, and if we show the claimed byproducts, previously I have claimed one byproduct, which is seen here. Now let's go and track any product. So this is where you track a product. So I'll just search for any bottle of wine. So I'm taking an example of Pinot Noir bottle of wine. From here you can just try Respire, which is a carbon emission tracker at every stage of the food supply chain. So this is the food supply chain of the Pinot Noir bottle of wine. You can see the product had grown from wine to grape, then the harvested cluster, crushed grape, and you can see the details of all the food byproducts which had occurred at every stage of the food supply chain. You can also claim the byproducts, which gives you if the vineyard had any row number or any specification, you'll be seeing it here, and you have the vineyard's name. You can click on claim, and we are doing 2 transactions of claiming the sampling grape. After claiming, you can see the status which tells you that the claim is successful. And once you go to my inventory and click on display my inventory again, you are fetching the inventory. It takes a bit of time again because it is trying to do the same thing of fetching the data from the ResilientDB, fetching the data from the ResilientDB, and then checking the transactions at the Firestore and fetching the data from the ResilientDB. So after you fetch it, you will be able to see the claimed byproducts which were done in the previous stage. So if you show the claimed byproducts, you can see that we have claimed the sampling grape. These are the claimed byproducts. You can log out, and we have a login screen and then the register screen. And yes, this is about Arrayán. Hope you enjoyed the video, and please try Arrayán at arrayán.resilientdb.com.